So we're now going to start our discussion of the Search with Parallel Splitterator case study by talking about the PhraseMatchSpliterator and the various fields that it defines. So remember, the PhraseMatchSpliterator is an implementation of Splitterator that we're going to use to do parallel splitting. And there's also a sequential version of this program that has a splitterator, but it doesn't go as far as the one we're about to look at. The fields are the same, but the behavior is slightly different. And what's key to notice here is that SearchStreamGang, the framework, the example, uses the PhraseMatchSpliterator for both sequential and parallel streams. There was a famous Saturday Night Live skit many years ago starring Chevy Chase, and he talked about this thing called Shimmer non-dairy floor wax, which was both a dessert topping and a floor wax. So this is kind of the same idea. PhraseMatchSpliterator is both something that can be used with sequential streams and with parallel streams. So let's focus on the sequential portions, just so that you understand that part, and then we'll make the main focus be on the parallel portions. So this is where this all fits in to the overall processing of this program. We take a list of strings, which are the works of Shakespeare, and we go ahead and then we have a list of phrases, and we convert those phrases to a parallel stream, and then we call the search for phrase method using the map intermediate operation. So for every phrase in parallel, we're going to search that work for that phrase. So here's a very simple example. If you're familiar with Hamlet, there's a famous little soliloquy by Polonius talking to the Queen Gertrude and the King Claudius. And this is one of the things he says. He says, "Brevity is the soul of wit." And of course, the funny part is, if you've ever seen the play, or if you ever saw any of the movies, you know that there's anything but brevity to describe Polonius. He's a windbag. He goes on and on and on. And this scene is no exception to that. He's just going on and on and on. But brevity is the soul of wit. So what we want to do, if we want to search for brevity is the soul of wit, we want to make sure we can find brevity is the soul of wit. And we're going to do this by splitting the whole work of Shakespeare up into chunks and then searching them in parallel so that we can more quickly identify whether this phrase exists in that input. Now, we need to make sure that we split the input evenly as much as possible, because if we don't split evenly, we're not getting a big benefit from parallelism. So the fact that we're storing these things as an array list makes it easy to split evenly and easy to split efficiently. However, we have to be careful that when we split the input up into two chunks, we don't split the input in such a way that the phrase we're searching for crosses the split. Because if we were to split the input in a way where brevity is the soul of was the end of one chunk, and then the next chunk started with wit, we would never find brevity is the soul of wit, because we would have split the input in a way where we couldn't actually get a match. So a lot of this parallel splitterator's logic is going to deal with not splitting things across the phrases we're actually looking for. So before we talk about the algorithm for doing this, let's just briefly talk about the data structure. So PhraseMatchSpliterator implements the splitterator. Splitterator is an interface that defines a bunch of methods, the two most important of which being try advance and try split. And we'll take a look at both of those. There's a whole bunch of fields that are defined in this splitterator that we need for both the sequential and parallel use cases. There's a few things in here that are only for the parallel version, but we keep them around just to make it easier to not have two versions. And you'll see that there's the try split method we'll talk about, I think, in the next lesson. And that actually gets modified, or it modifies some of the fields. So not all these fields are final. The ones that are not final are going to be modified in try split. So the M input field is the work of Shakespeare we're dealing with, like Hamlet or Macbeth or Twelfth Night. M phrase is the particular phrase we're going to search for in that input, in that work. We have a pattern field that contains the regular expression representation of the phrase, and that's going to be used to make the searching work effectively, because otherwise you'd have a lot of work on your hands to do the searching properly. We have a thing called a matcher, which works in conjunction with this pattern and the input in order to search for the phrase in the input using the regular expression. We have another field that keeps track of the minimum size that we want to use to perform a split on the input. And this is one of those things where you need to do some tweaking. But typically, I think I take the work of Shakespeare and split it up into like 4 pieces or so and run those in parallel. If you split it up into too fine level of granularity, you're just doing a lot more work because word searching is pretty fast on a string. And then the final field here is the offset. And this is used for the parallel splitterator to make sure we keep track of where the phrase occurs in the overall work of Shakespeare when we split it up into chunks. OK, so those are the different fields in the phrase match splitterator.